we are here, why do we have to talk about the heavy-duty vehicles, is because if we look at the road transport sector and if we look at the pollution level that this sector has caused, the transport sector is accountable for 1/4 of the greenhouse emissions in Europe. If we look at road transport, this is definitely the biggest contributor among all, because it accounts for 70% of all the emissions of the transport sector. And heavy-duty transport industry on the road is probably the biggest part of it, because it takes approximately 25% of all the transport emissions, so not only road. Anyway, since 1990, heavy-duty transport emission has constantly increased, despite a slight reduction in the latest years. However, we are still at levels of emissions which are higher than the levels of 1990, so levels of 32 years ago. And this is definitely not compatible with the target that the European Commission has set as part of the Fit for 55 package, which is the reduction of the emissions by 55% within 2030, and the climate neutrality by 2050. However, we here have two projects which are working in the good directions, and they're going to presenting what can be done in terms of reduction of emission and in terms of improvement of energy efficiency. So the two projects are Aeroflex and Long Run. They both address issues on heavy duty. I think maybe a few words on Aeroflex. Aeroflex is looking more at the energy efficiency of a powertrain by developing a distributed powertrain, and it also has developed some aerodynamic features for the truck, on top of safety features and smart loading unit features. While Long Run is developing innovation more on the internal combustion powertrain itself, with some clear targets on emissions reduction of CO2 and NOx by 30%, and is targeting a 50% peak thermal efficiency for the engine. And on top of this, it also develops connectivity features and yes, also looks at electrification features for the powertrain. I will be introducing also the two speakers. So for Aeroflex, we have Ben Kreier-Hagen. Ben is the project coordinator of Aeroflex. Aeroflex now has concluded in September 2019, and it started in Aeroflex concluded in September 2021, started in 2017. Ben has more than 35 years experience in the mobility and logistic industry. He has in-depth expertise in trend analysis, in the creation of scenarios, product stewardship, mobility and logistics, and public funding programs. He developed research and innovation roadmaps, including project ideas, and held many workshops and interviews with focus groups to discuss and mirror future challenges, needs, and requirements. Ben is engaged in many platforms and associations such as ALICE, AirTrack, IFRTT, the Metropole Region of Munich, EUCAR, and ASEA. Since October 2017, he is the leader of the project Aeroflex. And in early 2018, he got involved in the EIT urban mobility community. Currently, his role as of interim director of innovations in BE-CAT, Bank Consultancy in Automotive and Transport. His vision is sustainable mobility for freight and people, being efficient and affordable with minimal negative impact on the environment, health, safety, and society. And for a Long Run, we have Dr. Lukas Virnic. Lukas studied mechanical engineering in Aachen University, where he received his PhD in 2016, for his work on modeling of knocking combustion for gaseous fuels. He joined FEV Europe in 2016 as a technical specialist for commercial gas engines, where he became product manager for medium and heavy-duty engines and senior product manager. He is now product manager commercial for hydrogen engines and in FEV, and is also the technical coordinator and chairperson for the project long run. Okay, so we will start with Aeroflex. Ben, I'll leave you the floor. Thank you. The presentation is...
Good morning.
Excuse me. We have to open the Aeroflex presentation.
Ah, okay. I thought it was open.
Just need to click on your name.
Mm-hmm.
To launch the presentation.
Okay. Good morning, ladies and gentlemen. As Luca introduced, Ben Kruijnhagen, I will start with a very short video about the project. Good morning once again. The project Aeroflex stands for aerodynamic and flexible trucks. And through this short presentation, I will explain what we mean with aerodynamics and flexible trucks. The project had a consortium out of 23 leading organizations. You can see them in the top right corner. And we started in October 2017. And our final event was last year in September 2021. Due to the COVID situation, we had a delay of 6 months. Our total funding was €9.5 million and the project cost was 11.95. And one of the key success of our project was the engagement of a stakeholders group. So representing all relevant stakeholders out of the logistics world, the transport world, all people who have to deal with trucks day in, day out. And we started in our project with 36 members, and at the end of the project we had over 70 members really engaging to help this project to become a success. What was the focus on the project? Finally, the outcome was that we had 2 demonstrators to show all our innovations. And the innovations were focused on the vehicle, like the distributed powertrain, a smart power dolly, the active and passive aerodynamic devices, and active and passive safety systems in the new front-end design. So this was part 1 of the project, focus on the vehicle and focus on the energy efficiency and the safety, the survivability in crashes up to 50 kilometers an hour. Secondly, the second pillar in the project was about the loading units, because a truck is built to transport cargo from A to B, and we have to improve the utilization of the loading units, and we have to look at how can you use intermodal loading units, the so-called European modular system. So we looked at new modular loading units to be more efficient in loading the loading units. We looked at 2 software systems. The first one is Puzzle, which is a software based on warehousing and how can you quickly calculate how you should load a loading unit in the optimal way to find the best balance between weight and volume to ensure a maximum utilization. The second software pack was a cargo volume detection system, camera-based, to observe live what is the available space in a trailer or in a body to quickly decide which kind of load can be added to the loading unit itself. And then the fourth, we had a project in the project which was called Trailer to Train. As I said, we are looking at intermodal loading units, so we involved also the rail people to see how can we better communicate between road transport and rail transport to make a more efficient transport in general. And this was also one of the key focus that we were looking at, the overall efficiency in long-haul road transport, where we have said we want to have a target of between 18 and 33%. Now you want to say this is a very widespread, but this is logic. If you look at the transport of cargo and you look at the diversity of the transport of cargo, then you will find out very quickly that this is a bandwidth which is very much in line with the possibilities and the opportunities you can find as real efficiency improvement in a real-world use case characteristics. All in all, we had 31 use cases which we analyzed with our vehicle concepts and loading unit concepts to see can we meet the target of 18 to 33% energy efficiency. Further, we had technology blocks where we had concrete targets on the specifics of energy savings, energy efficiency, and we have looked at standardization of interfacing and how can we share components for higher economy of scales. And last but not least, we have looked intensively at the front-end design of a truck because we are now all able to have elongated caps, and we have looked into the elongated caps. How can we improve the active and passive safety to avoid injuries and fatalities in crashes? At the end of the project, we can conclude we have met all the targets and we have even done better. There are some restrictions. As I said already, in a real-world use case portfolio, you have to accept that there is a spread in efficiency improvement. Simply, there is no more opportunity and that specific use case. And at the other hand, you have to deal with barriers, like legal barriers, like operational barriers. So somewhere there is also a limit. And if that is not taken away, the limit, then yeah, the efficiency is as is. The second important one was the energy efficiency improvement from a flexible advanced powertrain. We were looking into a distributed powertrain where we started that each vehicle unit is part of the powertrain and it is an electrified powertrain, but in the prime mover, so in the tractor unit or in the rigid, there is still a combustion engine. So this was a pre-step in advance that we are now going in the next stage. Can we replace the combustion engine by a further electrified drivetrain, either battery or hydrogen powertrain? But we found out that if you really want to have high efficiency levels, you need plug-in always to make sure I can start with a full battery. Let's start with the aerodynamics. The aerodynamics, we had a drag reduction of 21% compared to the state of the art. And how we built up this analysis, we did an intensive development and quantifying of a set of all kinds of active and passive aerodynamic features for the complete vehicle. So we did not look only at the front vehicle, we also looked at the complete vehicle, so the trailer, and in case of an EMS1 vehicle, we also looked at the other trailers. So we built up CFD models. We built up a wind tunnel model to validate what we did as analysis and CFD calculations in the pre-phase. And then finally, all this work ended then in one demonstrator, fully equipped with active and passive aerodynamic features. like adjustable spoilers, a gap reducer, a bow tail. We had side skirts which were activated to lengthen, to close the gap between the motorway and the side skirt at a certain speed. We had coverage of the dolly, and we had under panels, and we had a diffuser in the rear of the trailer. And with that, all these features, we had then the opportunity to reach the reduction target of 21%. Looking at the elongated front-end design, we did an intensive analysis of what kind of accidents are happening on the European motorways there where long-haul trucks are running, so also express roads and highways. And we find out that the elongated cap end is a very nice opportunity to include active and passive safety systems, like a new type of underrun protection for a collision with a car, with a passenger car, to secure the passengers in the car. We found out that we can use soft materials in the elongated front. If we have a collision with a pedestrian, then he will not injure it in that way that it is serious. Of course, and that we found out, that we need to include active safety systems, because the first goal is to reduce the speed of the collision. And it was important, we found out, that there is no way that if you have a truck-truck collision, you can find passive safety system to reduce the injury of the truck driver and the damage. So the active safety systems are there to reduce the speed of the collision and to protect then the driver, because that's the only way to protect a driver in a truck-truck collision, and secondly, to protect a pedestrian when there is a collision with him and a truck. As last step, we had a long discussion with the Euro NCAP, and we have proposed to start a process that you can talk about a Euro NTCAP. So is there a possibility for future truck design, specifically on the elongated front, including the passive and active safety system, that there can be built up a kind of a protocol? How can you access new designs that we will meet the target that there are no injuries and no fatalities? So in other words, to reduce the number of collisions and to reduce the fatalities and injuries in line with our goals. The distributed powertrain, we have looked at that for 3 reasons. We see that trucks do have an enormous variety in transporting of cargo every day. So the weight and the volume use is defining by the end the total weight of the truck. And for the operator, it is extremely important that he can use one concept truck, one truck, for different applications. So we dive into what are the applications of cargo groups and truck configurations, which are the most beneficial to do the transport of cargo in the most efficient way to reach efficiency when it is about energy, but also cost per ton kilometer. And by that, we started to think about this distributed powertrain to use the vehicle in the optimal form, have there the drive axles where you need them, to make sure that you have an energy management system of the total vehicle, that you can use the energy at that axle or to recuperate energy at that axle where you can do that at that certain moment. And we want to use the vehicle to maneuver in the maximum best way on terminals, but also when this kind of vehicle is leaving a motorway and entering a hub or a terminal area, you can split this kind of vehicles, and then this dolly is able to transport the trailer independent from the truck. So in other words, you can maximize the handling at terminals and yards, which is extremely important if you look at the pre- and post-haulage transshipments of cargo from truck to other modes or at the end destination. So we built a demonstration yes, still with a combustion engine, with a dolly which has a steerable front axle and an electric-driven rear axle with a battery pack. And in the trailer, we took the trailer from the Transformers project, where we had an electric axle and also its own battery pack. Then we had, of course, a communication between the front truck and the trailer to make the communication of the energy used, the torque used, the recuperation use, and the maneuverability use in the best way. And if we have an outlook into the future, I said it already, in our project, the front vehicle had a combustion engine, but tomorrow it can have a battery powertrain or a fuel cell powertrain, and the function of the vehicle is simply the same, but we have then a 100% emission-free vehicle. Looking at the loading platforms, we had, as said, developed two systems. It was first of all the cargo volume detection system. Two grid cameras are observing the room in the trailer, and the shipper can immediately see on the screen what is load available. You could connect that up with a cloud, so you can really go to a marketplace to sell space in a vehicle. The puzzle software is there to optimize the loading of a trailer in the best volume weight balance. And the third one was the new loading units to have specifically for palletized goods and non-palletized goods. We found a way, how can you load this kind of cargo without using traditional pallets, without using no pallets. And that is an enormous time-saving issue. Then we had the double stack trailer for specific combination cargo of volume and weight, so that you can also here optimize the loading. As said, we had a collaboration with some other projects. The first one was Cluster 2.0, where we were trying to use the animalus in real-time applications, and we found out that we have time savings of 43%, purely because you don't have traditional pallets. You are really packaging the cargo in the way the end customer needs, and then you can really be very quick in pre- and post-haulage handlings. With the puzzle software and the double stack, we did some use cases with Procter & Gamble, and we could increase the utilization from 49% up to 90%. And then with CFL, Intermodal Terminal in Luxembourg, we did a trailer-to-train test where we brought our new trailer concepts to the rail to prove that we can transport also aerodynamic optimized trailers on a rail wagon. And together with the rail people, we developed a new concept. How can you improve the road rail transport of cargo through Europe? And I was very amused and I was very happy that at the final event, the rail people were standing there and they were presenting this concept, that they were saying, why not using EMS vehicles to bring as much as possible either trailers or bodies, swap bodies, to the rail terminal, bring them from A to B to the next destination over a long distance to decrease the number of trucks on highways. And at the end, you have then the so-called distribution runs. And because it are all European modular systems, you can use then a huge variety of vehicles, which are all standard vehicles, to distribute them to the end users. And of course, you can use this in a vice versa way. So this is a model of how can you really make the best out of new vehicle configurations using these innovations out of Aeroflex and combine that with rail transport. What does that mean for the mid and long term? Because we had also one partner in our project, ALICE, the Alliance for Logistics Innovations, and we have looked into what is the future of transport, and it is a huge transport demand increase. if you compare 2010 to 2040, then we have to speed up our research and innovation activities to much more even improve the efficiency of cargo transport. So we have said we have to engage freight transport and logistics company to test the technologies and to bring them in real operation. And we should not say always, no, this is not possible. It is possible. We have to more focus on palletized goods. We have to focus on the empty kilometers, and we have to look at industry to industry and across the regions, that we have to look at how can we maximize the impact. And can we combine the EMS system with zero emission technologies, as I said already in my previous slide, to simply look at use the technologies in combination with EMS so that you can better improve also railroad. And we have, of course, to look at the weight and dimensions directive. How can we slightly adapt it that you can open the door for this kind of innovations? And this has nothing to do that this kind of truck needs to run into a city. No, we are talking here about long-haul transportation of standard loading units. So the second drive was that we have looked into this legal framework. What is needed as a recommendation to adapt the legal framework that we can introduce this kind of technologies. And we designed even a roadmap which you can download from the internet, the pathway to June 2030. We made a nice bulletin that we said, imagine you are living in the year June 2030. What have we done to meet and to implement these innovations, that we have a system that the right truck with the right cargo is at the right time on the right infrastructure to minimize the impact on the society and the environment. And at the final event, I was very happy that we had 100 people at the location because of COVID, but we had over 200 people from worldwide visiting this event as a global live stream. And to close, I want to show our movie.
Welcome to Aeroflex, high-capacity road freight transport, focusing innovation on smarter mobility solutions for smarter policies. The Aeroflex project set its main goal in an efficiency improvement of up to 33% for long-haul road freight transport, and to do so, it brought together a wide consortium of partners and a sounding board representing stakeholders from industry, research, academia, engineering, logistics, authorities, providers, and society. A wide-ranging study was the first step in the project, and it helped to identify and define the innovations to be developed. From the beginning, it was clear that all these innovations would require changes and adaptations in the current European directives and national legislations. To meet the goals, objectives, and challenges, the project focused on the powertrain, the aerodynamics, the loading units, and the front-end design of the complete vehicle. An innovative approach regarding the powertrain was introduced with the so-called distributed powertrain, which aims to reduce energy consumption and optimize the drivability of the vehicle. It consists of an additional electric powertrain in the form of a dolly to power the trailer units. With this innovation, the trailer unit can be fully integrated into the truck's powertrain. Thanks to the vehicle in the loop tests performed at TNO, the development time was greatly shortened. This electrically driven dolly was created from scratch by Fraunhofer and Van Eck. This innovation not only supports the capabilities of the complete vehicle combination, but also makes it possible to split the vehicle into single units that can be remotely controlled, allowing the e-dolly and trailer combination to maneuver autonomously. The aerodynamic drag, which is one of the largest resisting forces experienced by heavy-duty vehicles, was another of the innovations the Aeroflex project focused on. Developing CFD models and a 1:3 scale model tested at the FCA wind tunnel, a wide range of aerodynamic features were developed that drastically reduce the energy consumption of the complete vehicle. Combined combined applications of these aerodynamic features have proven to reduce drag by more than 40%. 14 different aero features were then installed in a demonstration vehicle to determine real-world savings. All these innovations were developed without affecting the cargo capacity and allowed the trailers to be fully compatible with intermodal operations. This study also resulted in a new front-end design that enabled the addition and integration of new active and passive safety devices to help avoid collisions, injuries, and fatalities with other road users. A safety evaluation of safety systems like emergency braking, lane keeping, and side guard warning was conducted in the most relevant safety-critical scenarios and demonstrated the ability of these systems preventing crashes and are included in the project recommendation for future cab designs. Aeroflex also developed software tools, puzzle, and a volume detection system, transforming loading units into smart loading units to maximize loading space efficiency and modularization of cargo units in order to optimize loading space in the trailer units. Adaptations to the aerodynamic trailers were included to maximize multimodal operations. All these innovations were tested, demonstrated, and validated during the project. It started with the test of daily use vehicle configurations, evolved through the use and test of state-of-the-art semi-trailers from Smidge Cargo Ball and Van Eck from the Transformers project to the testing on the track and open road of the multi-vehicle configurations, equipped with the 14 aerodynamic devices and distributed powertrain developed during the Aeroflex project. Guided by the knowledge base of IDIADA, these innovations have resulted also in the creation of a book of recommendations which collects the project's vision on how to create the regulatory framework to have the Aeroflex vehicles on the road soon. To close, we must thank all partners and sounding board members for their endless engagement, contributing to the success of the project. The Aeroflex project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under Grant Agreement number 769658.
Thank you.
Thank you, Ben. And also thank you for the consortium for all this work. Okay, now is the turn of Longren, Lucas. Obviously, we keep the question at the end for later, also for Aeroflex.
I click OK.
Yes?
Okay. I guess we had enough virus in the last years, so I didn't want to put another one on the laptop. So, also welcome from my side, Lukas Förnig from FEV GmbH Europe, and I'm more than happy to present you today as a chairperson and technical coordinator our interim results from long run. So we have started in January 2020, and we have a duration of 42 months, which makes up end in June 2023. And our total budget is about 33 million euros, where basically the EC funding is at 24.9. The project consortium consists of 30 partners. We will see them later on the during the presentation, and then highly recommend our website, where we try to have as interactive material as possible. So today I will give you a glimpse on the presentations we have uploaded there and the information. So please make use of that and try to interact with the website. We're really, really happy to also receive your feedback on that, because I guess doing these short 15 minutes of presentations, doing really technical deep dive is super, super difficult. Therefore, I will give you a glimpse on certain topics to basically show you then also the message from the website. So first, wanted to start basically with some interesting comparison, where you have on the one side basically effectiveness. So the effectiveness is basically defined by doing the thing right, or efficiency is defined by doing the thing right. and effectiveness is basically do the right thing. So basically, what can we do in the long term is basically think about doing the right things, and in the more short-term thing, we can do thinking about the thing right. And another really important topic I want to make here as well is basically the awareness, so reduced impact on the environment. And I see that this awareness for impacting the environment is a little bit too weak within the public recognition. I did a speech in Baden-Baden 2 months ago where I basically showed the dependency of CO2 emission with the wealth a country has earned, so basically with the production capacity of wealth of a country, and that pretty much correlates to each other. So the richer you are, the more CO2 you produce normally. And one thing which is really strange about it, if I think about my smaller kids and also to my parents, what they always said is basically the kids should have a better world to live in than we had, and they should have a better living. And everybody in the past was basically relating that sentence, so as I see it now, to money. So all parents try to make their child a more livingful life by earning more money, spending that to them, so they can have more freedom how to spend it and anything else. But the thing is, if I would ask you what is your actual bank account worth, everybody would, I guess, have a rough number. If I would ask you what is your annual CO2 production and what is your basically CO2 production during your whole life, most of the people struggle. And to give you a rough number, you have a CO2 consumption budget of roughly 50 ton. It can be higher, it can be lower, it pretty much doesn't matter that much. But as a European, you produce 10 tons a year. And that makes you basically eating up that budget in 5 years. And that is a thing everybody should think about if he wants to stay on the planet for 5 years, or maybe a little bit longer. And to make us stay on that planet a little bit longer, I guess we have to take some actions, and I would like to introduce you to those. So our objectives is about energy saving. Thing is, road transport is producing a lot of CO2 emissions, absolutely correct. But what happens if there is no road transport? I guess some of you have faced the shortage of coffee this morning. Now make up your mind, without road transport, there is no coffee at all. So that is basically showing, yes, we have road transport. Road transport is responsible for CO2 emissions, but we are so much used to consume goods and all these other things that you cannot erase it from one point to the other. And that is basically where efficiency then is key, to increase efficiency of our road transport system to reduce CO2 emissions. Because thinking about that 10 tons I just said, and that is just without flying. So vacation adds quite something on that, and especially business trips via plane as well. So that 10 ton is an average, and I guess if I look through the room here, it might be 22, 25 ton on average, because we all go to business trips, we are really wealthy, and we also do a lot of vacation. So efficiency is key, and basically we have 6 objectives dealing with that topic. First objective is energy saving, and there we also kind of take over things developed in Aeroflex. So we are, in some terms, the consecutive program to that, since we take over findings from there and introduce it into our demonstrators. But we exclude the effect of plug-in hybrids here in that 10% energy saving. We want to develop a robust realization of ICE technology for the use of future fuels. And I would have wished that the action or the actuality of that topic wouldn't be that high. But thinking about fossil fuel prices on the refueling stations nowadays, you can see that you have read that in LinkedIn, they post a lot, and HVO is basically nowadays competitive on the price with fossil diesel, for sure due to some unforeseen shortage on fossil fuels, but actually that is a point which everybody expected to be far in the future, and now it's happening today. So that usage of renewable fuels in existing fleets is getting more and more important, And with the pressure of that global crisis, now more and more OEMs also release their engines for the usage of HVO and other alternative fuels. So I guess there a really big progress is ongoing and can really, really make a difference in using fossil fuels. So we have utilized that in dual fuel mixtures, also with methanol, and in a well-to-wheel approach, you can save more than 90% of the CO2 emissions with that. Talking about the internal combustion engine, increasing efficiency is still possible, and we have the target to increase that efficiency beyond 50%. 50% is just a number, but it basically means the engine is producing more power than losses. If you reach that 50% and go beyond that, you create more power than losses. And that is a really significant target. But as always mentioned, Fit for 55 is not only CO2 emissions, it's also increasing basically air quality, and therefore also after treatment system is in the scope, where we have the objective to reduce NOx, CO2 and hydrocarbon emissions, especially in extended conditions. That will be introduced with Euro 7 as well. And within the long-term consortium, we have defined clear targets to demonstrate these reductions under extended conditions with our demonstrators. All about that is basically on the demonstrators, and then we have a second path, which is dealing with simulation. So we will introduce a simulation framework to support the design and development of efficient powertrains, including hybrids, and to demonstrate optimal combination of technologies. How is that whole thing then basically realized in the consortium setup? Super difficult to understand because of all these lines, but actually there are some really central messages in that slide, and these central messages are at the end. So we have agreed within the consortium to summarize informations and results. So basically our target is to make information available on an easy accessible level. So not putting their slides with technical details, doing 1 hour speech on minor changes we did with great effort and great achievements. We have set the target to create roadmaps on 4 different points, and that is CO2 reduction, electrification connectivity, thermal and emission reduction. And these roadmaps are created to summarize all project results from the work packages and condense them to make information accessible. And that is really a key target and also a quite difficult task, I can tell that, to basically align all this information into a kind of view everybody can understand. And for sure, also future regulation is one topic. And we develop a framework for simulation where then every OEM is able to hook up its own hybrid strategy to Vector, because if a technology is not recognized in Vector, it won't be introduced. So as long as there is no impact on the certification of CO2 emissions, OEMs won't introduce any changes, and therefore it's super important that all technologies which should be introduced into the market are also reflected within the regulation framework. So to give you basically that outlook, what is happening within long runs, we just heard that aerodynamics are super important for basically reducing energy need on the vehicle. So the less resistance you have to overcome, the less work the powertrain has to basically generate, and therefore also efficiency increases. We take over some aerodynamic measures from Aeroflex and then dealing mainly with the powertrain efficiency to lower fuel consumption. You all know the roadmap, 2025, 2030, 50%, 30%. That's the actual status, which is in the process for reviewing. But actually, that is, at the moment long run was initiated, the target. So coming to that powertrain efficiency, and that is basically now one of our use case clusters. I showed these roadmaps at the beginning, and what I brought with me today is basically a certain deep dive on one roadmap to give you an idea how the information is available on the website and how we will proceed also with the other roadmaps. but since use case cluster 2 is basically the most advanced roadmap yet, I've chosen that one to give you an idea how the information is presented. And to not deep dive into thermodynamics and engine technology, but basically we have different source of losses. And actually, if you reduce the losses, you increase the efficiency, and that is at the end key of that roadmap. How do we come to that 50% brake thermal efficiency? We have a baseline. Here it's the example of the diesel engines. So we have diesel engines which are compression ignited, and we have natural gas engines which are spark ignited. The diesel baseline is for sure a little bit higher, and the target is also higher. But since if you use natural gas in the vehicle, you have a 25% saving on the CO2 emissions just by nature of the fuel. Therefore, in CO2 emissions, they level more or less up. So starting with the baseline model year 2018, we have basically already demonstrated at the status of today an improvement bringing up engine efficiency to 48.1%. Combustion improvement basically means we have a more efficient combustion of the diesel fuel within the cylinder. We have lowered the losses in gas exchange due to elaboration of the turbochargers. Heat transfer and friction reduction is a point we will further investigate, but these are basically results also derived from single-cylinder engines, and their friction reduction and heat transfer, or basically friction reduction, is not that easy to evaluate, but that will happen on the multi-cylinder engines. And then we have energy recuperation, and we are at 40.1%, further targeting that achievement of 50% brake thermal efficiency. But I guess already a great achievement to get to that point. And we will deep dive on the reasons why we got there a little bit later. So that is how the use case cluster 2 roadmap and the results are presented on the web page. So it's maybe too small to read now, but I wanted to give you that overview, how we do it. So we have basically a description of, for example, that measure compression ratio increase and peak cylinder pressure increase. So you have a short description that you can somehow understand what is meant by that and what is basically the change to the engine. Then we have split it up into advantages. What is really the advantage of that measure? And we have also listed the risks. So what might withhold you from introducing these changes to the engine? And then we have basically a ranking within the assessment where you see the BTE, so brake thermal efficiency impact. What is basically, what do you get out of the engine for that change? We have a point of invest, and we have judged the maturity level within 2025 to 2030 to make, or to give you somehow an idea if that is really introduced into serious production or not, and what further steps it would take to introduce it. And with that, we have basically summarized the results from the ongoing investigations. So you will also find, for example, the fuel injection system, which is then described in a really detailed way. You have the advantages. One further advantage for sure is also reduce particle matter emissions, but also it has impact on the fuel efficiency of the engine. And you can click through all these measures, and it's really, we tried to keep it on a high level, easy to access for people, but also have a technology deep dive that it also contains value for people really skilled and interested in that point. So please make use of our website to get a further insight on these results. I put HVO here since to that actual topic of Ukraine crisis and getting more independent from normal feedstocks which are introducing energy into our energy system. So HVO is basically non-fossil based fuel. It's made of hydrogenated vegetable oil, and it's basically a transparent paraffinic. And from our point of view, one of the most promising alternatives to diesel fuel. There was a lot of investigations on alternative fuels. There were tailor-made fuels for internal combustion engine. Everybody thought about how can my fuel ideally look that the engine is super happy to consume it. How can I change them in the macroscopic and microscopic structure that they are really made and tailored for combustion engines. So you can achieve great improvements with that technology, but it all comes up to the point where there are so many options that none of them really makes it. And for a fueling industry, they don't put 20 new refueling devices on the fueling station. So they have to really focus on one. And also making the actual fleet able to also use these new fuels is a super important topic. And the HVO has really a huge benefit that it fulfills the EN 15940 regulation and basically is more or less quite similar to diesel. So it's at the end not making the most promising and most advanced fuel, is basically keeping the burden to introduce it super small. And that is where HVO has a really great advantage. And most of the OEMs are now also introducing their basically certificate that you can use HVO with the engines, and we see an increase in usage and a great chance, whereas it might not improve engine efficiency that much. So you see here a rather low rating on the BTE impact, but for sure you will generate the benefit then looking to well-to-wheel, where you can reduce CO2 emissions by roughly 90%. Also looking to the natural gas engine, also that is part of long run. So you see a roughly same increase here of 4.5%, split it into different measures. And also here we have basically the assessment of the different technologies introduced to that combustion engine available on our website. Also intake miller is one of the key things we have introduced there. To come to an outlook for the next 6 months, we have basically single cylinder investigations ongoing on the DAF engine. And also they started the multi-cylinder engine investigations. The Volvo engine is already validating, or has already validated some of the efficiency increase measures, and then is now to also starting the multi-cylinder engine investigations. FPTI, who is doing the natural gas investigations, they will further enhance so-called Swamble combustion concept and also then transfer that technology more and more to the multi-cylinder. And really important or interesting topic is coating, where basically the engine cylinder liner as well as the piston is getting coated to keep more heat basically in the combustion chamber. A further outlook I would like to make here is basically why are these ongoing investigations so important, and what is about the coffee in the future? So how is it getting to you in 2030? And that is an outlook I took from our consulting colleagues. They presented that in the engine conference in Baden-Baden. So you might think, okay, it's an engine conference. If they would present it on the battery electric forum, it might look different, but they actually take the same graphs wherever they go. So it's independently from the conference they presented. And you see here basically that's a sales forecast, so that is not fleet, that is sales, that are the vehicle introduced to the market. And for sure there will be a certain ramp up of battery electric vehicles introduced to the market, but in 2030, still 3 out of 4 trucks introduced to the markets are powered by ICE and hybrid. So that makes it really visible that working on these technologies nowadays is still important. You cannot stop working on these technologies, letting away some CO2 savings because the future might be different. So in the short term, doing things right, I guess it's still needed to develop and enhance the technology of internal combustion engines, but for sure doing the right things, we see that increase of battery electric vehicles and also fuel cells, whereas there's also a scenario where a hydrogen combustion engine is playing a major role and basically splitting the sales between fuel cell and H2 ICE. So that is a really interesting future. Just to give you a rough example or a rough time frame, my retirement is 2050. So I still have to deal with all these topics, and that is why the future is also important for me. And that is a really interesting thing to come. So I'm really happy to get in contact with you, to connect with us. Visit our webpage, talk to us in the pause or in the breaks. I'm really happy to answer your question also in the discussion.
Thank you, Lucas. Thank you, Ben, as well. Good morning, everybody, from my side. We've just heard 2 comprehensive presentations on large projects with improvements over things like technical, operational, safety and logistics. So there must be plenty of questions and answers. We've got about 15 minutes or so now for question and answers. If people want to ask a question, may I please ask you to state your name and affiliation? We're on record here, being filmed, etc., so that would help always. But please, questions from anybody? Raised hands, or has everything already been covered? Here at the front, first of all, and then secondly, Michael. Please go ahead.
I'm Bernard Jacob. Hello, I am Bernard Jacob from University Gustave Eiffel. My question is for Ben about Aeroflex. I wanted to know if you considered in this project the possible introduction of electric road system in the future and how it could impact the future development of heavy vehicles.
Should be on.
Yes, it works. Thank you, Bernard. No, we did not consider, because we really were focusing on the vehicle as the vehicle, and we were looking at the vehicle units, how we could distribute the powertrain into the vehicle units. And we have said that the scope in the project is not what is happening in the tractor unit or in the rigid, so the prime mover, because we took there the position today it has a combustion engine, knowing that in the future it can be battery electric, hydrogen, it can be an electric road system. So we even had some discussion with Alstom, for example, to look at could it be possible to have inductive loading whilst driving. So, but we did not go into depth yet. So we took the standpoint, let's focus on the vehicle with the combustion engine today. Let's look at what are the advantages and the opportunities to have a distributed powertrain to maximize the energy efficiency and the vehicle drivability from that point of view.
Thank you, Ben. Michael, please.
Michael Nöst, A3PS Austria. I know Ben from our preparation of DigiTrans in Upper Austria. And thank you all for your presentations, and especially Ben for the connection of road and rail. Nice and very helpful approach. My old question is, what is your experience and your meaning about truck platooning? Yeah, you remember our discussion to have investigations in it. Beside your nice measures to have a better aerodynamic.
Of course, in Aeroflex we have not looked at truck platooning, although there was a parallel project at which was focusing on truck platooning. And truck platooning gives you, under certain circumstances, advantages. But if you have to look at a broader European scale, and you have really to look at all the transport missions through the whole European scenery, then you still have to look at the aerodynamics of a truck. Because it is certainly not the case that if you say, I have a truck platoon, that we can't forget about the aerodynamics. Because truck number 1 needs to be aerodynamic already. Then you have the second or the third truck, or maybe a fourth or the fifth. That depends on what is possible in the aerodynamic or in the intensive traffic circumstances. And also in the future, it will always be the case that truck platooning is not just like that possible. So looking at aerodynamics, because that was the discussion I can remember we had, does it make sense to look at aerodynamics? Because we will have truck platooning, so all the trucks are driving in out of train, and that is certainly not the case in a daily use. And it really depends on where are you on which type of roads, and because the European roads is not only highways, you have also express roads, you have national roads, etc., etc. So I have, or we have a strong belief in the consortium, aerodynamics is one important issue to look at because it can reduce the drag, and by that it can use the energy need to drive a vehicle on the road. So I think that was repeating what we have discussed. I thought it was 2 years ago when I quite remember. And to jump on your remark, intermodal transport, I strongly believe we should do a lot of effort to bring more cargo to the rail, but we should not dream that the potential the rail people have is also limited. Due to the long time of introducing of new technologies, we are actually talking with rail people again for a follow-up project of Aeroflex, and the process of working with rail people is completely different from the process of people in the truck industry. We are much more able to have quicker decisions and quicker changes, where the rail people have to live with the processes and the procedures they are in. And I do understand this now better than 4 years ago, because then we started with the Aeroflex project. So we first met on the rail people, and it was a little bit of friction, but at this moment we have a very good collaboration with them, and from both sides we believe we should work on this topic.
Thank you, Ben. Other questions from the audience? Ian, on the right-hand side there, please.
Hello, Ian Fire from Bosch. Thank you, Ben. Both presentations were fantastic. In terms of exploitation, Ben, it sounds to me like the logistics companies are lining up at your door with the order forms for your results and want to implement it as soon as possible. Is that correct? And the second question is to link both projects. I might have missed it in the presentation, but the question is, what is your timeline for getting your results into Vecto?
Good question. I had exactly the same.
The first question, if I look to the logistics people who were involved in the project, they were really highly positive about the part we did regarding the trailers and the loading units. And I know that, for instance, the Anomalous, the puzzle software, and the cargo volume detection system, and the double stack trailer, they are near to be at the marketplace. So that is something which is pretty soon available, because the double stack trailer is already there, but not in the sense with all the aerodynamic devices. So that is the next stage which the trailer builders are working on. The electrification of the trailer is very close to market entry. We have 2 trailer builders in Europe who are going to bring these trailers on the market very soon. 2023 they will be available. And yes, of course, the start of those trailers is for the temperature controlled transport of fresh food. But these trailers do have electric axles and have the possibility in the future to be connected up with the control unit in the prime mover. So this development is there and will come to the market. Your second question was how to deal with the vector tool. Unfortunately, the time in our project made it not able to pick up this point, and we know that was a weakness, but yeah, we had to live with certain constraints, and we surely are working on the follow-up project, I think, as you are well aware of, and there we need to tackle this point as well. Yeah, yesterday we had a discussion about this, so it will be part of the follow-up project as a little part in this issue. Because yes, it is already said, if it is not in the vector model, it is hard to introduce. But my biggest worry is, can we also have a adaptation in the legislative framework? Because you have the so-called 25% rule, which is the weight on the drive axle. And it would be perfect if you could have drive axle in each vehicle unit, because then you have a much better possibility to have a much better drivability and use of energy in the vehicle as a complete vehicle. We are too much focusing on this prime mover in the vehicle and forgetting about all the weights we are pulling. And I know there are two philosophies. There are people who are saying, keep the trailer dumb, but there are also philosophies who can say, make the trailer intelligent and let it operate it within the powertrain and in the complete function of the complete vehicle. And now Christopher is already raising his hand, and I can imagine what his question is.
And I would quickly comment on the long run vector interaction. So first of all, I have to also thank the partners. I forgot the last slide. I will do it in that way. Thank for the partners and also for the funding to the European Commission to make that project happen. And then for the vector and long run, maybe it was a learning from the Aeroflex, but we included basically Theo Graz and Mr. Hausberger into the project to have a close link project and also vector within the project. And that is foreseen to be ready when the project ends. We will have this interface for the hybrid interaction ready to be then proposed to be integrated into vector. And I guess that is also a learning from the maybe the past. We have to measure our success of the project not only by the demonstration of the technology, we have to measure the success of the project also with basically taking into account the recognition of the technology in legislation, because that is at the end the key for the success of the project. And that is where then also the HVO topic is a really important one for us, whereas we can basically do a lot of development with HVO, as long as it's not reflected in the legislation and in the final outcome for the OEMs to utilize it or to make it possible to utilize it, it's super difficult to get that ramp up.
Thank you, Lucas. You've raised some very important points there about how we go further with the legislation. We've got about 5 minutes left, so we can still take some questions. Krista first, and then I see a question coming at the back there as well.
So this is Krista Trehan from Scania. I do not have the question that you think I will, but I would like to say that I appreciate you, Lucas, that you realize that there is a market for the combustion engine also from 2030. With Scania had a target to sell 50% electrified trucks by 2030, which is more ambitious compared to what you showed. But even so, 50% will still have the combustion engine, which means that you're completely right. You must continue to develop that one. Thank you.
Thank you, Krista.
Yeah, thanks. Maybe quick comment on
Lucas,
the numbers.
yeah.
That was long haul. So that was long haul trucking. I guess when Scania refers to 50%, it might be the whole truck fleet, right? And that was, sorry, I maybe add that is long haul trucking.
We make mostly long haul.
Okay.
Thank you. So we had a question right at the back there, or 2/3 of the way back. Thank you.
Yes, thank you. Thank you very much. I'm Janis Humor from ELES. First, thank you for the really terrific presentations and the progress you have done. I have one question, both for Lucas and for Ben, that goes a little bit into the direction of the SICAM partnership. Have you thought about also of the reduction of the drag and by this the efficiency of the trucks when they would be perhaps driving in a convoy and by integrating the vehicle-to-vehicle communication, which goes a little bit then also further on into development of the, let's say, wireless driving, that means autonomous driving of the vehicles, because we all know if the vehicles, the trucks would driving one behind each other, it would reduce the drag and by this efficiency improvement very much better. Thank you very much.
Thank you for the question. I'm happy with the question because, yes, we have looked at active and passive aerodynamic features, and active because we found out very quickly in the project that the circumstances under which a truck is driving on the roads is varying the whole day. So you need to make the aerodynamic features active so that they can adapt themselves. How is the vehicle running under what circumstances? That depends on the speed. It depends on other trucks around the truck. It depends on the wind. It depends on many climatological circumstances, but also traffic circumstances. So using active aerodynamic features give you an endless opportunity to connect it with, yes, with the platoon, with when the truck is driving autonomously in the future, that the feature can adapt itself to make the maximum out of it when it is about drag. So we did include that in that part of the project, that we were looking at how can you make it active in that way that you also can connect it up to other vehicles, because that was the Ethernet communication system we developed in the Aeroflex project to work also with common systems, not to include again a new connector and include a new hardware. So really try to incorporate it in the vehicle technology as it is at this moment, so that in the next steps of automation you can include these features as well.
And for long run, that would be a perfect title for the next presentation I would do, would be use case 1, where long run is dealing with connectivity. And basically the approach from long run in that point of view is that we have developed a cloud-based service where you can type in all the attributes from your truck, your loading, and the route you want to take at a certain time. And then that cloud-based service is basically calculating the best efficient route for your specific setup. So if you might have a plug-in or electrified truck with an internal combustion engine, it takes that into account for the choice of the route you're going to take. So it's really specific to heavy-duty trucking. The driver can activate or can access it via a tablet, and then that cloud-based service is basically taking into account all the actual conditions, traffic, and all other things, and then giving you the right choice of routing, really specially dedicated to the to your unique vehicle. So it's not like a navigation system, it's much more precisely taking into account your actual weight and the routing you want to take. So that is our approach for connectivity, because, and that is one thing, sometimes platooning is a smart thing to reduce drag, but at the end there are also heavy-duty trucks are not the only ones on the road, there are also cars, and if you would assume you have to spread the trucks in each and every exit, because you also have to allow some, I maybe talk too long, some cars to exit the truck, to exit the highway, and that is also something you have to take into account.
Lucas, thank you very much. No, you didn't talk too long. You were right on time, and that's what the note was saying there. We've had a good discussion here. Maybe we should have touched a bit more on some of the operational benefits that we've seen in some of the projects and the impacts of HVO and so on the future vehicles. But I'll hand over now to Luca just to close the session for us. Thank you.
Yes, thank you, Simon. And anyway, thank you everyone once again for the questions and for the presenters for the answers and for the presentations before. Now in the program there is coffee break, but before you go, I also would like to mention that downstairs there are several booths where you can learn about the Horizon Europe funding opportunities. There will be colleagues from the European Commission, so you can also ask questions during the coffee break, and don't forget to visit. For the rest, in this room, the next session will be at 11 with green vehicle architecture, component and system for electrified vehicles. I think then this can conclude the session. Once again, thank you for everybody, and see you around.
Well, I think it's better to get a start, even though people seems to be still busy with coffee, maybe with the queues. So I will just take the time. They come with some introductory statements on what we are going to deal with in this session. The session is on architecture, components, and systems. So if you want, the lower level to the session we had yesterday on the whole vehicle. This is where a lot